types of attacks and threats, right? Today we will discuss how we will establish the security by using different techniques or tools, right? So here we are planning to discuss three different types of security mechanisms, right? So the one is authentication, the next one access control, third one is cryptography. By implementing these three different techniques or different tools, we achieve a certain level of security, right? So tell me, what do you mean by authentication? You already know. Just tell me in your own words, what do you mean by authentication? Any volunteer? What do you mean by authentications? If you authenticate something, it means what?
I want to verify something whether they can access whether they authorized person or not.
Okay.
There are so many factors here. Using that, we can authenticate that user is authorized person or not. Two-step
Yeah.
verification, like.
Yeah. Yeah. Authentication means we can verify whether you are the user or not, right? Who you are, right? So already if you have a software system or whatever the things, right? Maybe if you think about the physical server rooms or whatever the different components of a organization, right? They define, right? These are the people, they have rights to access the systems, right? So or to access the certain devices, right? So already they allocated some people to access or to handle those systems, right? So if someone they don't have any allocations, right? Just they are uh, using or try to access the system, we are considered as a unauthorized, right? They are not authorized to access, but they are using some loopholes or they are using some tactics they are trying to access, right? That is not an ethical thing, right? So authentication means who you are, right? So whether the appropriate guy, the person who allocated for that particular access, he will access the resource or not. That is the meaning of authentication, right? What do you mean by access control? So access control in the sense, right? We will limit the access, right? So even if you think about a software system, right? We are giving limited permission for some people to modify the things, right? We are giving some people only visible the things, right? We are giving some access control as a just only do some comments on the things, right? So likewise we can control control the access of a particular resource by using different levels, right? So if it is admin access control or user access control or client access control, depending on that we will define different set of permissions, right? So if we implement access control, that is also we can secure our resources or information system, right? I think you know what is cryptography. I think you already learned cryptography, right? So cryptography in the sense we are hide the real message, right? So we will hide the real meaning of the message, right? By look at or by reading the message, we cannot get the meaning. That is we can call cryptography, right? We are encrypt and decrypt the things, right? We will hide or we will uh, close. We hiding the content of the messages or the data packets. That is we can call cryptography, right? So we can hide the things. So we are planning to discuss these three things, right? I think you're already familiar with those things, right? Just I will revise, right? So if you're planning to implement security, you need to focus on these areas, right? So let's say if you're planning to establish a cloud into your organization, right? So maybe you're purchasing some cloud resources from one of the service provider, maybe AWS, Azure, right? So as an admin people or as an organization people, right, the top level managers, you need to verify these three things, right? Authentication, access control, and cryptography, right? So maybe if you are purchasing cloud features, right, we need to communicate throughout the internet, right? So definitely we need to verify the encryption, right? So the data communication happen throughout the encrypted channels, right? Otherwise, if there are any intruders, they can monitor your communications, right? That is one thing. The next thing, authentication. Authentication means we will provide different accounts for different users, right? So if it is a development team, we are giving some different user profile, username, password. Then by using that authenticated credential, they will access that cloud services, right? Similarly, if you are project managers or if you have a quality assurance, we are giving separate roles, right, for the cloud facilities, right? So, but why we are giving different roles? different authentications, right? Then it's easy to identify. If there anything happened, we can easily identify whether which guy has responsible for that unintentional thing. So whether they are purposefully do something, right? We can find out or we can identify that person, right? Identify that person or identify that ID, right? Who is responsible for these activities happen in the system, right? That's the reason we are authenticating, right? Access control in the sense for the different users, we are giving different access levels, right? So if you are a freshers or trainee, they are giving very limited number of facilities to access within their systems, right? Maybe we are not giving to all the operations, right? Root operations, create, retrieve, update, delete operations. We are not giving for the freshers, right? Maybe what will happen if we give that permission, sometimes because of awareness, maybe they will do some mistakes. Because of those mistakes, the entire system becomes collapsed, right? So if you ensure these three things, we will uh, verify we have a certain level of security into our information systems, right? Now we will look at one by one. So I already explained, right? Okay, just think about authentication, right? Authentication mean I already explained who you are, right? So I will explain with the practical example, right? Just think about uh, uh, next to your house there are so many neighbors are located, right? So just find out, right? Uh, one there is a house next to your house, right? Normally you know who are the people stay in the house, right? Normally we know, right? If it's a neighbors, we know who are the people stay in the house, right? We know that. Maybe we are from born, we have survived in that particular house, right? So we are familiar with the neighbor houses, right? So we have a good relationship with them, right? So now what will happen, uh, we know who are the people, uh, who are the owners of the house, right? Who are surviving in the house, who are the relations of the house, right? So we know, right? By nature we find out those things, right? So as a neighbors, if we have a neighbors, we know the information, right? Now what will happen, abnormally there are some new people are survive, or there are new people are visiting your houses, or there are some new people try to access your house, right? If you notice, what did you do in your neighbor's house, right? There are some new people, the new faces you are find out, or some people continuously find try to enter your house, right? Or that isn't abnormal things, right? So normally you know who are the people stay in the house, right? Who are the people live in the house. So it doesn't matter, right? If you find some new faces or some abnormal behavior, right? What did you do? Tell me, what did you do if you find some abnormal things?
Must to identify those persons, sir.
Yeah, we must need to identify, or maybe we will verify, right? Whether who are the people, right? Maybe you can communicate with your neighbor house people, and we can ask who are them, what is the purpose. Likewise, or if the neighbors are not living in the house, maybe you can inform to the police, right? There are some abnormal new faces are surrounding the house. Likewise, right? So what it indicates, that is authentication, right? So you know who are the people normally visit the house, and who are the people survive in the house, right? So if you find some abnormal things, or if you find some new faces, they are not familiar with the house, then you that creates some doubtful, right? Doubtful behavior, right? Then we react for that one, right? So that is the authentication. The same concept we will apply for the systems, right? So if you have information systems, right? So normally the person, they have some identity numbers, right? Maybe they have some username and password, right? So if they use that particular username and password, it indicates that exactly the person who give the permission, he will access the system, right? So if try to access some unauthorized people, right? So it means someone without authorized access, someone try to access the system by using some illegal things, right? The system, it will find out, right? So there are some abnormal things happen. So they will indicate, or they will notify those things to the response team or to the admin guys, right? So that is we can call authentication, right? Authentication in the sense we can find out who you are to try to access the system. Similarly, who are the people try to access the house or the neighbor home, right? So similarly, if you find who are the people try to access, that is we can call authentications, right? So to complete the authentication, there are two different tasks you need to complete, right? If you are doing authentication, right, internally you are doing two things, right? So the one thing, we need to identify the object, right? After we identify, then only we will authenticate, right? So there are two tasks, two processes you need to complete to complete the authentication. To complete the authentication process, first we need to do the identification process. After you identify, then we can authenticate, right? How we can do the identification? How we can do the identification? Tell me.
User credentials. You
Normally,
can use
let's
the
say,
user credentials.
yeah, user credentials, especially in the sense they are ID cards or they are unique numbers or they are NIC numbers, likewise, right? So in this house example, they are faces, right? So their face is an identity, right? So you know who are the people normally visit the house and who are the people living the house, right? So based on that, we know the familiar the faces, right? So face is an identity. Similarly, if you look at a system, their username, right? Especially their Gmail IDs or their username, sometimes they have a specific ID card numbers, right? Or sometimes those information we consider as a identity details, right? So that is the identification process, right? So if you enter the correct username or ID card number or correct unique things, that indicates that person, right? But the important thing here, identification details are not private, they are public, right? That is an important thing, right? The identification details we cannot maintain as a private thing, right? Identification details are publicly available, right? So it means your email ID. Just think about, you have a credential username and password, right? Your identity is your email ID, right? The username is your email ID. So we cannot hide that identity, right? So identification details are publicly available, right? So what we can hide only the password, that credential authentication details, maybe we can consider as a private things, right? So that's the difference between identification and authentication, right? If you are completing an authentication task, first you need to identify. After the identification process, you need to do the verification, the authentication process, right? So just think about, right? If you send an email, right? You are sending an email to your friend, right? So how your friend identify? Based on your Gmail ID, right? So your email ID, based on your email ID, he will identify whether he's my friend or not, right? So the identification details we cannot maintain as a private things, right? That's always public, right? So we can maintain personal or private email IDs, right? We can maintain only the passwords, right? We can maintain as a private the credential details, the password or that token keys. Likewise, we can maintain some private things. Anyhow, your identification information is public, right? So your email ID is a identification details, right? That's a publicly available things, right? So these are the things explained by here, right? So yeah, here they are explaining these things, right? So based on your identification details, they will identify whether this email is coming from that appropriate guy or not, right? So normally the identifications are public thing, right? But if you think about the second task, authenticate, verify, right? So for the verification purpose, we are using some aspects, right? Maybe we are using some passwords, or maybe we are using some biometric features, right? Maybe your fingerprint biometric feature in the sense that biological features, fingerprints, face recognitions, right? The voice commands, maybe your yeah, your iris, the iris shape and color. Likewise, nowadays we are using different features for the authentication purposes, right? So the identification is public thing, right? So we cannot hide the availability of identification information, but anyhow, we can maintain as a private things for the authentication details, right? So authentication details we can maintain as a private, right? Any questions? Okay, now we will look at what are the different types of features we can use for the authentication, right? So I already told you, right? Authentication complete in two tasks, right? First, you need to do the identification, that's publicly available thing. But if you do the authentication process, that is a private thing, right? So to authenticate something, we can use three different types of private information, right? We can we can categorize as that particular user has, right? The particular user has in the sense maybe they are using a specific token keys, right? Or they are using some two-factor authentication device, that is we can call the user has, right? Similarly, the second type, the user is in the sense maybe their biometric features, their fingerprint, their facial shape, right, their iris color, their blood vessels. Likewise, we are using some other information that is we consider as the user uh, is. The third thing, the user have, right? Sorry, I already mentioned, right? User has, user is, right? The third one, user knows, right? So user knows in the sense their username passwords, right? Their password we are using, right? Or sometimes they are using some PIN numbers, right? These are the things we can consider as a the user knows, right? So for the authentication mechanism, the authentication private information, we can categorize into three types, right? Something the user knows, something the user is, something the user has, right? So the something the user know in the sense maybe they are maintaining a passwords, right? They are maintaining the PIN numbers, right? Sometimes they are using some phrases, right, as a secret handshake, right? Or maybe sometimes we are using some security questions, right? Even if you forgot the password, based on the answers you are providing for the security question, they will allow you to reset the things, right? So something the user knows, that is one type of things we are using for the authentication purposes, right? For authentication purposes, we are using one type, something the user know. As a user, to try to log in your Gmail account, you need to remember the password, right? That is we can call something the user knows. Sometimes you are using some PIN codes, PIN numbers, right? You may- Sorry for that. Mm, yeah, you can see my screen, right? So we can categorize all the authentication details into three types, right? Maybe something the user knows, right? So I already explained, right? Sometimes we are creating some PIN numbers, right? To unlock your mobile phones, we are using PIN numbers, right? So if you remember the PIN number, then only you can access, right? That is the authentication process, right? So if you correctly enter the PIN number, it indicates you are the person trying to access the device, right? Sometimes we are using some patterns, right? Pattern locks, right? So if you put the correct pattern, then only it will show you you are the correct persons, right? Similarly, the passwords we are using, right? So we can categorize all the different authentication things. So authentication details are private, right? So identification details are public, authentication informations are private. So we can categorize all the authentication details into three types. Maybe whether it's the user knows, right? Something the user is. So user is means that is exists in his body, right? Biometrics things, right? Good example is biometric features, right? Your physical characteristics, your fingerprint, right? That is unique for each, right? Your voice pattern, right? Your voice commands, right? Sometimes your face shapes, right? face locks. Nowadays, it's possible. Irish we are using to unlock the things, right? So these are by default, we have physical uh, characteristics, right? These behaviors or these features are inbuilt in our body, right? So that is we can call something the user is. That is one type of things nowadays we are using to authenticate. But compare with the previous one, it is highly secured, right? Also, it is highly costly things, right? So if you compare with the something the user knows, it is less security compare with the something the user is, right? If you think compare the user password and body biometric features are highly secured compared with the passwords, right? But password using a password is a less expensive. But if you are using a biometric features to implement the biometric security in your into your systems, that is a little bit highly costly task, right? That is the difference between these two, right? The third one, something the user has, right? Something the user has in the sense, sometimes we are using some token keys, right? Sometimes we are using another device, right? So two-factor authentication, we are using another mobile phone. They will send a code, then we need to enter the codes, right? Sometimes we are using some RFID tags, right? So to access the particular systems, right? So these things we can call something the user has, right? So they are keep those things with them, that equipment or that devices, they need to keep with them. That is we can call something the user has, right? Something the user is in the sense the biometric features, right? Something the user knows, these are the passwords and PIN numbers, other things, right? So these are the types of authentication uh, mechanisms, right? Okay, okay, just a image explained, right? Authentication is based on something you know or something you are, something you have, right? So something you know in the sense the passwords or PIN numbers, you remember the things, right? Something you are as a biometric thing, something you have, that is your devices or secondary devices we are using to access, right? So these things we can call as a three different types of authentication techniques, right? So just they are explaining throughout an example image, right? Okay, now we will look at one by one, right? Something you know, right? So I think you know the example, something you know is the passwords, right? So use a passwords. That is a good example for something you know, right? Maybe we are using some security questions, right? So maybe while you are creating some online banking facilities, they will ask you to provide some security questions, right? You need to answer the security questions, right? So if you remember the security questions and the answers, then only you can reset the passwords, right? So that is also we consider as a something you know, right? But the important problem here is a less secured one, right? Passwords or security questions, it is less secured one. Why I am telling it's less secured? Tell me. Why I am telling something you know are less secured? What is the reason I am telling that one? Something you know is a less secured. Why? Tell
Maybe
me.
some other also can know about that.
It means can you elaborate?
It- Uh, maybe other also they have guessing using some guessing. They have also using
Yes, yeah.
same thing as a password.
Yeah, if you are using something you know, right, there are so many possibilities to try to someone find out those things, right? That is the important thing. So if you are using something as a password, right? So normally the human they have some nature, right? They are creating the password based on the information or based on the characters that is highly related to them, right? So I will guarantee no one create a random passwords, right? If you create a password, definitely they have some meaning with you, right? That is the important thing. If you create something, definitely they are related to your personal things, right? Maybe your family members or your parents or your spouse or likewise, right? So if you create a password, you are connecting those things with something that's the important thing, right? So now what will happen if you are using those type of things? Give me a minute. So likewise, there are so many possibilities, right? So we have dictionary attacks, right? We have brute force attacks, right? So there are so many ways try to steal the things, right? So by using those techniques, they try to find out the password, right? There are so many possibilities to guess the password. Why I am telling, anyhow, if you are creating a password, definitely they have some relationship, right? Normally, no one can put a password randomly, right? So if you create a password, definitely they have some relationships, right? Do you agree with me?
Yeah, sir.
Even you just think about yourself, right? Each and every one, we are maintaining so many passwords, right? So can someone tell me I'm not I'm using passwords, these are not related to me? Anyhow, you have some meaning, right, with your personal things. Maybe you are matching with your date of birth, you are matching with your parents details, or you are matching with something that is related to you, right? So the hackers, what they are doing, they try to guess, right? If they know more information about you, by using that knowledge, they are using different combination and try to guess the password. That is a big challenge with the something you know, right? So if you are using with something you know, you have a big challenge with that one, right? That there are so many possibilities for guesses, right? That is a big challenge we are facing, right? What do you mean by rainbow tables? I already explained. Tell me. By using rainbow tables also, they try to guess the password. What do you mean by rainbow tables? Tell me. Any volunteer?
Hash- Hashing tables, sir. They
Yes,
have.
similar to the hashing tables, right? So maybe if you are using some encrypted things, right? So they are getting that entire dictionary words. They create a hash value for the entire dictionary words, right? Then they are matching with the hash values. Based on the hash values, they will find out the passwords, right? That is we can call rainbow tables, right? So if you are normally we know dictionary attack in the sense they are matching, putting all the dictionary words, right? Sometime nowadays, what will happen? We are a little bit secured, right? So we are not serve the password directly that plain text, right? So we apply some hashing techniques and we can serve the hash values in the database, right? That is one type of techniques we are using to secure the password, right? So even uh, if someone hack your tables, or if they look at the tables, user admin, username, password tables, they just look at the username. But we already know username is a public thing, right? Username, user details are we cannot hide. But anyhow, we can hide the password, right? So for hiding purposes, we apply some encryption techniques. Even if they hack the table, they can't look at what are the things are included in these, right? Then what they can do, they can create some rainbow tables. Then uh, if they hack the table, they will find out the password hash value and match with their rainbow table. Based on that, they will find out the keys, right? So that is a reverse thing they are doing, right? They are creating a rainbow table. From the rainbow table onwards, they try to find out, right? So if you are, but what I'm telling here, if you are using something you know, there are more possibilities to do some attacks, or there are more, you have a big challenge to secure, right? That's why even if you notice, right, time to time, maybe maybe time to time, that online banking or the online or highly secure systems are increase the length of the password, right? Sometimes they will increase the different combination of aspects, right? If uppercase, lowercase, numbers, digits, likewise they are doing multiple combination. Only the reason is if they are using a specific type of uppercase and lowercase, they have a certain number of combinations, right? So the hacker, if the hacker has some advanced computing resources, by using those resources, they can easily find out the keys, right? That's why they are using length of the password. So they are increasing the number of They're increasing the number of characters or number of combination of different features. Why they are doing those things? To increase the security, right? So now we will move, right? The user. Okay, before moving to that one, right? Just look at here, right? This is what I'm told, right? You know, brute force attack. Brute force attack in the sense they are checking with all the possible combination of passwords, right? I already discussed in the previous class, one class. I already explained you, right? So just look at here. If you are using a four-character passwords, right? Only you are using numbers, right? For the four-character passwords, if you are using only numbers, so now what will happen? You have only four digits, right? Just look at here. If you are using four-character passwords, I already explained. Do you remember this? Four-character passwords, right? There are four digits are there, right? If you are using only numbers for these, right? What are the different possibilities we can put for here? Maybe 0 to 9. Altogether, 10 combinations, right? 10. Here also we have 10 combinations, right? Here also we have 10 combinations, right? Then here also 10 combinations, right? 10 to the power 4. How many? 10,000 combinations we need to check, right? If you check, if we need to check only 10,000 matches, right? So this is not a big deal nowadays. We have that much of computing resources, right? But just think about you are using lowercase letters only. You are using mixing up uppercase and lowercase. You are mixing with numbers, uppercase, lowercase. You are mixing with numbers, uppercase, lowercase, and symbols, right? So if you are increasing different number of combinations, the difficulty also increased. Did you notice here, right? What will happen here? 1 second, here 5 seconds, right? So if just think about if you have a 12-character password. Nowadays we are using 12-character passwords, right? So if it is only 12 characters are numbers, within 25 seconds they will find out, right? If you are using lowercase letters only, it means you have 12 characters. All the 12 characters are lowercase letters, right? All the 12 characters are lowercase letters in the sense it takes 3 weeks to guess. Even if you are using with uppercase and lowercase, 300 years, right? 2,000 years, 34,000 years, right? So what I'm telling here, by including more different combination of aspects into your password, we can increase the security, right? So that is the explanation of these tables, right? So if you are using with uh, something the user knows, you need to think about, right? Now we are in the 12 character passwords. How they are defined these length of the characters? Tell me how they will define the length of these characters. How they define? How they define these length of the characters? Tell me.
Didn't get you, sir. Can you tell it again?
Sorry. So how
Can
they
you tell it
decide?
again, sir?
Yeah, how they decide the 12 character is enough. How they decide? The company or the bank, how they decide the 12 character is enough. Tell me how they decide 12 character is
The,
enough.
the combinations of those are high and take time to reveal that. So
Yeah, that is correct.
so they
So
can.
how they will validate? Is it enough? So not only for checking the combination of different combination, number of different combinations, right? So they are thinking something. What is that? That is important factor.
They try to do some decoding with a password
Mm,
is encrypted. They try to decoding. It take too much time or it's not
yeah,
possible.
that
So they
that's okay, right? But some important character they consider, right? Based on that important character, they decide these up nowadays they are decided as a 12 characters, right? What is that?
Experience
Sorry, speak loud.
with their bad experience in a previous.
Not maybe not exactly they are using, right? But one important point, right? So maybe you notice before 2 to 3 years back, maybe they are using 8 character passwords, right? Now, most of the banks, they are using 12 character passwords. What is the reason for that? Why they are using 12 characters nowadays? The only reason it will increase the number of combinations, right? Maybe just think about why they can't introduce 16 character passwords. That is more number of combinations, no? If you look at the 12 characters, compare with 12 characters, if you are using 16 characters, anyhow, you have more number of combinations, right? But they are not using that one. Why?
Possible to remember that.
It's easy to remember 12 characters. That is not a proper reason. I'm asking proper answers. Let's think about brute force. So what will happen in the brute force? Tell me.
So short password easily cracked, but if it is long password, it is difficult to crack. Isn't it?
Mm, yeah, that even as a
If they
bank, yeah, tell me.
if they want to verify their password is good, they want to do some ethical hacking. That time they take too much time to check all the possible combinations and find the uh, loopholes.
Normally, right? I think brute force is what is the requirement for doing a brute force attack? Tell me. If you are doing a brute force attack, what you need? You need a computing resource, right? So how they will decide as a 12 characters, right? So just they will think about what is the existing uh, supercomputing powers, right? The computing is also impact, right? So up to now we have a what is the maximum, what is the uh, highest computing resource. By using that computing resource, how long it will take, right? That is the important thing, important decision they are making, right? So just think about i3 and i5, right? What is the difference between these two processes? The task it will concurrently doing is varying, right? So what do you mean by that processor speed? So nowadays we are using more number of virtual CPUs, more number of threads they are dealing by using virtualization technology. So what do you mean by that? Okay, just think about a simple example, right? You have two laptops, right? The same generation. Just think about you have a 10th generation, two laptops, right? Both are same generation. All the size of the hard disk, size of the hard disk is same, right? Anyhow, one is third generation i3, one is i7, right? So both are have 8 GB RAM, DDR4 RAMs, right? Both are has a 256 GBs of SSD. It means all are same, only the processor is different, right? So what do you mean by that processor? What is the functionality of the processor? The process the task, right? So if you are doing a calculation, how speedily it will provide the solution, right? That is a processing unit, right? So if you assign a task, how long it will take to do the computation, right? So now what they will check as a bank or as a security company, how they will decide 12 characters, right? By the existing computing resources, right? By the existing computing resources, it take around maybe 34,000 years, right? If you are using 12 characters, right? So while they are doing this survey, right? Maybe just think about we have a I 13th generation i7 processor, or maybe we are just think about by using supercomputing resource. Up to now, what is the highest computing resource we have? By using that resource, how long it will take, right? That is the measurement they consider to decide the number of characters to your passwords, right? Maybe what will happen after 4 years or after 6 years or after 2 years, what will happen? Your computing powers are increased, right? So that is the Moore's law, right? So I think you know what is Moore's law, right? Every 18 months, what is the Moore's law? Tell me. What is Moore's law? What is Moore's law? Did you heard this term? The processing power is double for every 18 months. That is a Moore's law, right? So processing power increase in the sense the processing speed will increase, right? That is a Moore's law, right? So what will happen? Definitely after 2 years or after 4 years, definitely they need to change the number of digits or they need to introduce something more important aspects. Definitely they need to introduce something new, right, to their security features, right? Maybe after 10 years back earlier, or after 10 years back, what will happen? We are using say 8-character password, not we are using special characters also, right? So that is also possible because at that time we have that much of computing resource, but nowadays we have more than that, right? So depending on those things, they decide the number of characters and number of combinations, right? So maybe nowadays there are some researches going on related to quantum computing, right? So just search about what is quantum computing, right? Once they introduce quantum computing, maybe 12 characters they will break within 1 second or 2 seconds, right? It's up to the computing resource, the technology what they are introduced, right? It is decide the number of characters as well as number of different combinations we want, right? So all the things are decided based on the computing powers, right? The existing computing power, how it will take to break, right? So if you are using a password in the sense that is not secured, right? Just keep in mind, if you are using any passwords, the meaning is that is not secured, right? The meaning of the password is how long it will take to guess the password, right? That is the thing. So password is not a strength, right? If you have a password, how long it will take as a hacker, how long he need to spend to guess the password. That is the thing they are expecting, right? So keep in mind, password is not secured, right? The time duration you want to guess that password, that is we can call your password is secured, right? The meaning of that one. Okay, next we will move for the next one, right? Okay, now we will look at what are the 12 steps an attacker try to determine the password, right? So not only these 12 steps, there are so many steps, right? I will list out some important steps here, right? Some more important steps hackers do to try to guess the password. How the hackers determine the password, right? Mostly they are using these techniques, right? Maybe you examine these 12 steps with your password, right? Is there anything included in your passwords, right? So these are the steps normally the attackers follow to steal or to guess the passwords, right? So first thing, they will check with the no password, right? So they will use without password try to access, right? That's the one thing. Sometimes what will happen, if they find out the user ID, the passwords also they are using the same user ID, right? That's the second step. So hacker is just they are not coming from the sky, right? So they are also humans, right? So hacker in the sense they use some tactics, right? Already they have enough knowledge. By using the knowledge, they are using some tactics and guess the password. That's the thing, right? Just that's not a rocket science, right? Just they have enough knowledge, technical skills. By applying the technical skills, they will try to do something, right? So these are the combinations. The second thing, they use username as a password, right? So they are giving the same username for password as well as username, right? They enter the username as a password, right? Sometimes it will work, right? Sometimes what will happen, if you have a username, right? Your passwords also derive from the usernames, right? So then they will check with different combination of derived passwords from the username, right? So if you have an email ID that or you have a user ID, so by creating different combination of passwords from the username, right? That is one type. So sometimes there are some common wordings are there, right? So maybe if you find in the internet, you can list out. There are some common wordings most of the people are using, right? Uh, the sequential order of the keys from the keyboard, or maybe they are using some password as a password. Likewise, there are some common wordings are there, right? So then they will check with the common wordings, right? So maybe sometime you are put as a 2468. Do you know that one? If I tell 2468, what do you mean by that? Tell me. I'm telling two fours, 2468. So how you can type? Tell me how you can type. If someone asks a password, I'm telling 2468. So what are the different combinations? Maybe two
We can
times
two times
four,
four likewise.
24, 6 times 8, right? That is one way. So that is one way. So 2468. Then what will happen? Sorry, I think you know, right? 24 times 24, 6 times 8. So likewise, so now we are thinking this is a strong password, right? As a hacker, they also know these tactics, right? So now what they can do, they will find out all the combination for these. Likewise, there are some famous password terms are there, right? So they will check with the matching criteria, right? So maybe sometime using this quadri, right? That the sequential order of the characters Q W E R T Y in the keyboard, right? Sometime ASD. There are some they know, right? The hackers they evaluate, right? That's why we are called as a hackers, right? So already they hack some databases. Based on that, they have some knowledge, right? So these are the common human behaviors, right? The human psychology is thinking on that base, right? So they will check with the combination of passwords, right? Sometimes they will check with the dictionary words, right? Sometimes they will check with the complete English words, right? Sometimes short words or complete English words from the dictionary, right? Non-English language dictionaries they are using for passwords, right? Similarly, they are using short college dictionaries. It means capitalization and camel case likewise, right? So I think no, the mixing of capital and simple letters, uppercase and lowercase letters mixing. So these are the different combinations they are using, right? Sometimes someone using right this way, right? Let's say someone's password, let's say 2005. Just think about someone's password is someone's password is 2005, right? So in his password, he put here 2. For 0, he have put as a O, right? 2005, right? Okay, someone's password LK. For LK, he put 1K, right? He put as a 1K, right? This is possible, right? Or maybe sometimes 2009, right? So here are putting 2OOG. For 9, they are putting G. So it means substitution of digit with letters, right? That's also possible. So don't think these are secure things, right? Hackers also aware those knowledge, right? So you are thinking, okay, for all the zeros, I am replaced with O's, right? All the 9 I replace with G. So don't think that is not a highly secured one. Hackers also, they know those tricks, right? So now they will check. They will check with the combination of these things, right? That's also possible. So they will check one by one, right? So anyhow, between these 12, they will find something, right? That's the thing. So the next one, the same substitution and capitalization with complete English dictionary. So dictionaries are complete dictionaries, right? They are using, right? Similarly, for non-English dictionaries, they are using this type of substitution techniques, right? Or they are using brute force attack, right? Typing all the possible combination of alphabetic characters, right? Or they apply the brute force attack, including all the alphanumeric characters, alphabet plus numbers and special characters. So these are the different ways they try to guess the password, right? So brute force attack is a example of try to guess the passwords, right? So these are some of the techniques the hackers try to guess the passwords, right? So I already mentioned this code, right? So what this code says, every password can be guessed, right? But the strength of the password is determined by how many guesses you require, right? How many guesses you need to check the password. That is the important thing, right? If you are using a password, it can be guessed. Only thing, the strength is measured, the password strength is measured based on how many guesses you need to guess the password, right? So keep in mind if you are creating, maybe you can check with these things, right? Maybe you already have different passwords, right? Just think about, is there anything matches? Is there any step is increase the guesses of my passwords, right? So you have already few passwords. Just think about, is there any these 12 steps are helpful to match guess my password. I already have a password. Just think about, is there any characteristics included in my password the hacker easily find out, right? Sometimes you are using username and password is the same, right? So only the username and password same. You are adding few more characters with the username, right? Then easy for the hackers, right? That special, normally what we just think about, one guy's username is Mohammed, right? So Mohammed at gmail.com, right? Normally what will happen, his password, sometime he will put Mohammed, maybe his date of birth year, right? Maybe 2005, or maybe he put 2005 and that date of birth entirely, month and day. So if a hacker find out those information, they try to match with those things, right? So that is a, that what that is indicates your password is weak. Hacker easily find out, right? So likewise, you can match each and every things what we are discuss here. Try to compare whether my password is easily cracked by the hackers, right? Okay, this is a normal thing, right? Previously, before 12 or 30, before 30 years back, normally this is the way we are stored the passwords, right? So in the ancient time, maybe not ancient in the sense, 30 to 40 years back, right? The introduction of internet and other things. These are the techniques we are using, right? So we are creating a table inside the system, right? Then we can serve the username and password, right? So this is a username, this is the password, right? So this is a plain text password. Now we realize there are some attacks happen, right? There are some SQL injection attacks. They will look at the tables by using SQL injection attack. They can visible the tables, right? Once they visible the table, right? If you are using these things, the hacker just find out this is the username, this is the password. Then they try to enter and try to access the system, right? It's easy for them. To avoid these things, nowadays we are using conceal password, right? Conceal in the sense we are hide the plain text, right? We are storing the passwords, applying some encryption or hashing techniques, right? So before you store the password, we are using some MD5 or SHA or different hashing algorithms. By applying the hashing algorithm, the hash value we can serve as a passwords, right? But the important thing, hash value we cannot be reversed back. Because of that functionality of hashing, again, if the user enter the password, just we are creating the same hashing algorithm, using the same hashing algorithm, we are creating the same hash value, then only we are compare the hash values, right? Actually the existing stored hash value in the table with compare with the user entered passwords hash value, right? That is the thing we are checking, right? So this is a normal, this is a conceal. Nowadays we are using this one. Even this is also now not secured, right? Now, even if you apply directly, hashing is not secure, right? Now we are using some salt and peppering techniques, right? So even if you enter or if you provide a password, with that password, the system it will integrate some few more characters, right? That is we can call salt and peppers, right? So altogether they are include some few more characters with the entered password, and they will again after that they will apply that hashing, right? Why they are increase or enhance the features or the saltering peppering salt and peppering techniques, day by day the security threats are increased, right? So they find some mechanisms, right? To avoid or to overcome those challenges, we are increasing new features, right? So even this one, applying the maybe SHA 5 or SHA 512 or SHA 265 algorithm is not secure nowadays, right? Nowadays, with these uh, passwords, they add some salt value or pepper values, likewise, right? In front, in front, some values, in the bottom, add some values. Then for the entire value, they applies the hashing, right? They apply the hashing, right? Any questions? Okay. Here we will discuss some generate good password, right? So we will discuss some important things while you are generating the password, right? I don't need to explain more about these things, right? You already, as undergraduates, right? You are an IT students, right? You need to aware how to create good passwords, right? So you need to choose the long password, right? Don't create 4-digit password or 6-digit passwords, right? So better you can keep long passwords, right? To avoid why we need to create long password. If you are creating a long password, definitely it will create huge time. You need to guess the password. Even if the hacker try to guess the password, he need to spend huge amount of time to guess the password, right? Also, we don't need to use actual names or words, right? Actual words. Maybe why we need to avoid actual words? Tell me. Just find out the reasons why we need to choose a long password. It will increase the time for number of combination, right? We need to do the huge number of combination to match the password if you are using long password, right? The next thing, if you are using the actual names and words that is available in the dictionary, right? So the hacker easily decrypt or guess the password by using some decryption techniques, right? By using dictionary attacks or something, they can easily find out the password. That's why we are avoiding actual names and words, right? So maybe better you can use a string you can remember, right? So without integrating meaningful things, you create some password, but you can easily remember, right? So normally what will happen, you are getting your first, your name, your first name, then you are adding your date of birth year, then you are adding some special, maybe your last name with the month. Likewise, that is a normal procedure. Nowadays, we are creating the passwords, right? So now what will happen, hackers can easily guess the password, right? To avoid those things, maybe you are creating some string passwords that is not related to your personal things, right? That is important, right? So the variation of multiple passwords, right? Use variants for multiple passwords, right? So mostly nowadays we have a problem, right? We have so many different accounts, right? So now at the time it's very difficult to remember all the password in your mind. So because of that, some people they are using the same passwords for different accounts, right? That is not a good thing, right? That is not a good practice. If you are using the same password for different account, there are more possibilities someone try to if someone tried to find your password for one account, he also using that same password, he tried to access some other accounts as well, right? So better you can use different password for different accounts, right? Also, you need to regularly change the password. Every 1 month, you need to change the password, right? It's a good practice, right? Better you don't write your password in anywhere, right? Even in your record books or even your device. Don't keep your password or write your password anywhere, right? Also, don't tell your password for anyone, right? So these are the practices you need to follow while creating a good passwords, right? Okay, previously we discussed something you know, right? Now we will move for something the user are or user is, right? So that is a biometric security features, right? As a human body, we have some unique features, right? So by using those unique features, we can implement as a passwords, right? That is we can call biometric features, right? The biometrics are biological properties based on some physical characteristics of the human body, right? The human body have some unique features, unique characteristics. That those things we can call as a biometric features. By using those biometric features, we can develop uh, authentications, right? Okay, here they are list out uh, different biometric features, right? What is the first part? Fingerprint, right? So I don't need to explain fingerprint, right? Each and every individual, they have unique fingerprints, right? So nowadays, maybe in our mobile phones, they have a system, fingerprint. Based on fingerprint, they will authenticate with whether the authorized person accessing or not, right? Hand geometry. What do you mean by hand geometry? The shapes of the hands, right? Size of the fingers, right? So you have some lines in your thumb, right? So based on those things, they will those things also unique for human, right? So maybe we are using hand geometry as a features, right? Retina in the sense your iris. In your eye, there is a black color, right? The iris we can call. So they have different colors, different shape, different size. So based on the iris also nowadays they are using as a authentication property, biometric security features, right? The voice, right? How the voice works, right? Tell me how the voice we are consider as a biometric feature.
Voice frequency, sir.
Yeah, the different voice have different frequencies, right? So if you measure the frequencies of different people, they are varying, right? So based on the frequency of the different voices, they are checking the frequencies and they will evaluate whether that person is actually the person or not, right? Handwriting, their handwritings, right? Each and everyone they have some specific style of handwriting, right? So nowadays we are using handwriting as a biometric features. They are signatures, hand motions, right? So hand motion in the sense they have some familiarities by nature, right? How they will move their fingers, or there are some other things, right? So those things also we are considered as a biometric uh, features to authenticate, right? Typing characteristics. If I ask you to type something, each and everyone have different typing pattern, right? So the finger movements are different, right? Your fingering typing speeds are different. So likewise, we are using something, right? Blood vessels, right? So the human blood vessels also we are consider to find out whether particular person or not, right? The face, right? The face we I don't need to explain, right? The human face now face locks are available, right? So we are using also we are using facial features, right? The shape of the nose, right? Eye shapes, right? Likewise, we are using some other biometric features, physical body features. That is, we can call something user is or are, right? So nowadays this is happened, right? So maybe that officers are now fingerprint, right? Previously we need to write and signature, right? Now everything becomes fingerprint and face. Right? Even in our faculty also nowadays they have implemented the systems, right? They have fingerprints, they have face recognition. So you need to enter your finger, then you need to show your face in front of that fingerprint machine. They will take the attendance for the employees, right? So why they are using, there are some challenges with the existing techniques, right? The writing, the manual diary maintenance. There are some issues. To overcome those issues, they using these type of biometric authentications, right? But anyhow, we have some issues with biometric features, right? Tell me, there are some challenges, right? Maybe in some societies they have if we ask to enter your fingerprint, they think this that is not a good approach to deal with humans, right? So they think only the theft or the thief they are asked to put the fingerprint. So they are think you are treat me as a criminals likewise, right? So that is one challenge, right? So if you are implementing some biometric features, some cultures or some organization, they are not accepting, right? Because of some their traditional things or their beliefs. Because of that, they are not accepting those type of things. Another thing you have that is very expensive compared with others, right? If you are implementing biometric security, right, it is highly expensive compared with that is a big challenge, right? So another thing, it's a single point of failure, right? Just think about always you are using a fingerprint, right? So now what will happen if your finger you have some knife cutting or whatever you have faced some accident because of that in your hands, you cannot enter your finger, right? Fingerprint machines. Now what will happen? You cannot put your attendance, right? So that's why nowadays they are introducing multi-factor authentication, right? Even if you are not put the fingers, maybe you are using the facial recognitions, you can put the attendance. So maybe sometimes you have some identification code, right? You have some token keys. So if you enter the key, uh, your fingerprint machine, it will identify whether this is from this guy, right? Likewise, we can implement multi-factor authentication also for the biometrics, right? Sometimes false reading, right? Also, in the biometric features, right, we are using not exactly matching, right? We are considered closely matching. Even if you have put the fingerprint, we are not matching exactly, right? So we are getting 85 percentage or 90 percentage of the matching is okay. Then we are giving that uh, attendance, right? We are marked the guy is attendance, right? We are not exactly matching, right? Closely matching. That is one big challenge nowadays we are facing with the biometric security, right? Maybe you, if you want, you can find out, right? If you are planning to do a research, you can do a research on that area, right? So now just think about what is the probability they are matching the fingerprints, right? So maybe you can purchase a fingerprint machines, right? Then you can check, right? Already you have a fingerprint database, whether what is the matching percentage they put those machines, right? Then you can propose a solution, right? How we can improve maybe nowadays 80 percentage of the matching they are considered for fingerprints, right? How we can increase the matching uh, percentage into 100. If you can introduce something that, right? It's up to you decide, right? If you have a research gap, you can do a research, right? So normally, if you are using biometric features, maybe if you are unlock your mobile phone by using your fingerprint, it will not exactly matching, right? It will check the approximate level of matching, right? Maybe 80 percentage of your fingerprint is matched. It will allow to unlock, right? It will not check for the 100 percentage, right? So keep in mind that. So there are some forgeries happen, right? They will get your fingerprint, and nowadays we have familiar with 3D printers, right? So by using the 3D printers, now what will happen? They will find out your fingerprint from somewhere else. Maybe if they are giving something, your fingerprint is matched. So if your fingerprint is there in that but particular equipment or particular device, right? So by getting that fingerprint, they implement 3D printers, and they will print the 3D uh, fingerprint prints, and they used to forgery, right? So these are some of the challenges we are facing with the biometric securities, right? Okay, the next one, something you have, right? So previously we discussed something you know, the passwords and PIN numbers. Then we discussed you, something you are or you have, right? You are, right? Something you are means that's a biometric features. By default, we have some physical properties. We are using those physical properties, that is we can call biometric security, something you are. Right now we are considering the third type, something you have. You are keep some devices or keep some different mobile phones or multi-factor authentication things. By using those things, we are create, right? So tokens, we can call something you have as a token, right? So if you have a multi-factor authentication device, so it will create a token and it will provide a token keys, right? So now what will happen? We are using that token key as a password, right? So anyone get these token devices? Anyone have any experience with token devices? Maybe if you move for the industry, right, you are getting this type of tokens, right? So if you are working on a big companies, right, maybe this type of tokens you can familiar if you are visit for the Virtusa, right? So Virtusa IFS, normally they are using this type of tokens, right? Token generators, right? So actually the purpose of this, they need to increase the security, right? So there are some projects, they are highly secured projects, right? So they are not allowed to enter to that environment, the say project environment, right? To access the project environment, you have already they are giving you some personal PIN numbers, right? So then you need to enter that personal PIN number to these token keys, right? Into the token device, right? To this token device by the company, they are giving you a unique password, right? They are giving you a unique password. That first you need to enter that password, right? Once that password is correct, this token key is generating a new password for every time, right? That password is valid for 60 seconds, right? So, so first you remember one password, then you need to enter that password into the uh, token device, then it will verify whether the password you entered is correct. Once the password is entered is correct, it will create a one password. This password is validate for 30 or 60 seconds, right? 30 seconds or 1 minute is validate. So between these 30 seconds or 1 minute, you need to enter to the system, right? So once you enter to the system, it will try to allow to access the system, right? So token means it's like a two-factor authentication, right? So two-factor authentication in the sense maybe we are using Microsoft Authenticator app, right? While we are creating Office 365 account, we are access the Office Microsoft Authenticator app, right? Every time it will create some new password, right? So that is the concept of this one, tokens, right? So the token key means that one, right? So the token in the sense that is the thing, same thing, right? So in the multi-factor authentication, Microsoft Authenticator app, every 30 seconds they are creating new passwords, right? So if you enter the password within 30 seconds, it's okay. Otherwise, you need to enter new passwords, right? After 30 seconds, it will expire, right? So after 30 seconds, you can't use that one, right? So these are, we can call something the user have, right? So now up to now we discuss authentications, right? So in these slides, I already told you we are explaining authentication, access control, and cryptography. These are the three different concepts I'm planning to explain, right? So now we get some idea about authentication. Authentication, who you are, right? For the authentication purpose, first of all, you need to identify the things, right? So the identification information are publicly available, right? Then the authentication details, that's a private information, right? For the authentication, we are using three different types of things. The user, something, the user knows something, there has something, there is, right? Something they have, something they know, something they are, right? So these are the three different categories we are using for authentication, right? Something the user is in the sense they are biometric features. Something the user knows, username, their passwords and PIN numbers. Something the user has, that is a token, keys, and two-factor authentication thing. So some RFID tags, right? By using the device, by keeping the device, they try to access, right? These are the three different types of authentication mechanisms. Now we are moving to access control mechanisms, right? Any questions up to now? Any questions?
No, sir.
Okay, if you don't have any questions, we will move for the access control, right? Okay. So the access control is you already aware, right? So if you look at here, right, if you visit for the administration building in the university, administration building, right, uh, some places they allow to enter as a student. You can, some places you can allow to enter, right? Some places you cannot allow enter to the rooms, right? So maybe they are put as a only, maybe if you think about the server rooms, they are not allowed to access all the people, right? So if you visit the administrative building, student welfare division, they are allowed to access, right? The students can access the student welfare centers, right? So that access available for students, right? If you look at the server room, they are not allowed to access to the server rooms, right? Similarly, if you look at just think about the lecturers, right? They have some certain level of accesses, right? So they can enter to the uh, server room if they have access permissions, right? So access control in the sense we are limiting the access permission for different type of people based on their qualifications or based on their levels, right? So based on the levels, we are limiting the access. That is we can call access control, right? So what is the purpose? We need to protect, right? So if each and everyone enter to the highly secured area, what will happen? if something happen, if something negative things happen, who are the one take responsibilities, right? So that's why they will limit the access control for certain areas, right? So the access control in the sense, we are limiting who can access, what can access, and how can access, right? If you think about or if you define these three aspects for a particular places or particular software or particular information system, that is we can call access control, right? So if you are controlling the access in the sense, you need to think three ways. Who are the people access, right? What are the things they can access? How they can access, right? If you define these three aspects, we can call that is access control, right? Maybe I don't know how many of you go through that AWS, Amazon Web Service, that course module. On that AWS, there are something called IAM, right? Identity and Access Management, right? There is a one module called IAM, right? One module called IAM, right? Identity and Access Control. Identity and Access Control. This is one of the service provided by cloud, AWS cloud, right? Amazon Web Service provide one service called IAM service. So IAM service in the sense identity and access management, right? The purpose of these IAM services to achieve this access control, right? To achieve the access control, the ultimate goal, right? Once you complete this IAM module, you can realize what are the different level of access control they are implementing within the organization, right? So especially they are considering three aspects. Who are the people access, right? What are the things they can access, right? How they can access, right? So if you define these three things, that is we can call you are defining access control policies, right? So if you think about who can access in the sense, right? We cannot allow to access all the people, right? Even if you think about the faculty, right? Some resources that is not allowed to access by the students, right? But some resources they can allow to access by the demonstrators, right? Some resources that can allow only by the lecturers, right? So likewise, they are defining some access control policies, right? So if you look at your final exam papers, right, the correction is done by that lecturer, right? They are not allowed to access by the demonstrators or the students, right? That's a normal procedure. So that is done by the lecturer, right? Similarly, if you look at some different places, they have some certain level of access control. That particular role only can access, right? That is we can call who can access. What can access in the sense, if you think about a system, there are so many different functionalities we have, right? But we are not allowed to access all the things. We are allowed only to access a particular resource, right? So maybe if you follow that AWS module, you have enough knowledge related to security aspects as well, right? That's why I am giving you that course module. It's helpful for the subject as well, right? So how can access in the sense, right? To access the particular services, we can use different ways, right? Maybe in your fourth year, right? We will discuss cloud computing, right? On that subject, right? We have different ways to access the cloud, right? So if you are using a Microsoft Azure or AWS, to access that particular cloud service provider, maybe we are using different techniques, right? Maybe we are using some command line interface, right? CLI based access is there, right? Sometimes maybe we are using user dashboards, right? UI based interaction is there, right? SDK based interaction is there, right? So by using which channel you try to access, that is we are consider as a how we can access, right? So just think about you are creating a virtual machine in the cloud service provider, right? So to access the virtual machine as a human, you can access different ways, right? Maybe you can use a remote desktop monitoring tools, right? That is one way of access. Maybe sometimes you are using SSH script, right? SSH port to access, right? So likewise, what is the medium to access the system we can call as a access control, right? So if you decide who can access, what can access, how can access, that is we can call access control, right? So these are the different techniques we are implementing the access control, right? So these are the different techniques we will implement the access control, right? Reference monitoring, access control dictionary, sorry, access control directory, access control matrix, access control list, privilege list, capabilities, procedure oriented access. access control, role-based access control, right? So role-based access control means depending on the roles, right? Even if you are a student, you have a different role. Even if you are a lecturer, you have different role. Even if you are an administrator, you have different roles, right? So that is role-based. Procedure-oriented means, let's say, if we have a different functionalities, let's say we have a IAM services, right? So IAM service is identity and access management, right? So each and every users we need to manage throughout the IAM services, right? Identity and access management service we are using to control access, right? That service is not available for all the users, right? So as a student, you don't have access for that one, right? But as an administrator, we have that access. Likewise, for different scenarios, we have different access control. We can call that one as a procedure-oriented access control, right? The previously that reference monitoring access directory or matrix in the sense already they define some matrices, right? So define some tables based on the table matrix they will allow or not for a specific access, right? So I will show some example, then you can easily understand, right? So the reference monitoring in the sense, just think about in front of that university entrance, right? There is a security guard is there, right? What is the functionality of that security guard? Tell me. He observe each and everyone enter to the university, right? So then they will note down the things. Also, they will check whether that guy is a uh, access permissions, right? Maybe if it is a vehicles, they will check whether it's a lecturer's vehicle or some outsiders coming, right? So reference monitoring in the sense they are monitor all the things enter and return from their uh, systems, right? So if you monitor those things, right, sometimes they are not allowed to enter to the university. If someone try to enter to the university, they are not authorized to the university. Maybe they are not a student, they are not a lecturers, or they are not a staff working in the university. They are not allowed, right? How they will do? They are just monitor, referencing monitor, reference monitoring. They observe the people who enter to the system and who outside the systems, right? So based on that, we are doing this is we can call referential monitoring. I don't need to explain. Right? Just you can monitor who are entered to the system. Right, the same concept we apply in the university entrance to the systems. Right. So if one try to request something throughout an API call, first we need to verify whether this guy has the access permissions to access that particular API. Right. How can verify? They have some credential. Right. In the header, they need to pass some information. Right. I think you learned those things in your service-oriented web architecture subject you learned, right? SOAP and REST web services, right? Request response model. At the time you uh, learn those things, right? In the header, you need to pass token keys. If the token is okay, then only it will allow to get the request and send the response. Likewise, right? So that is reference monitoring, right? Access control directory, right? So access control directory means for the different files or different APIs, already they define what is the access rights, right? If you look at here, he's the owner, read write permission, right? Owner, execution permissions, owner, read write. R mean read, W mean write, X mean executions, right? Similarly, so these already they're defined, right? The prolog.c file, they have these permissions, right? They are the owner. Owner can read and write the files, right? So likewise, they are creating some directory, telephone directory. Likewise, they define a directory for a particular system. Right? So if someone try to enter or access your system, they will check which file that particular guy tried to access, right? You have a different systems or different modules, they will check which module that particular user try to access. Now, let's say they are planning to access the biblog, right? So biblog in the sense, if someone try to access this biblog, right, it will check what is the access permission, access right that have, right? If it is the owner, only the owner they have read write permissions, right? So for this file, each and everyone they have access. Likewise, they are creating some access control directory. By using those access control directory, they can create or they can implement the access control, right? This is access control matrix, right? So for your system, you have different roles, right? These are some users, system users, and these are some of the user roles, right? By using these user roles, right? You have different files we have, right? Based on that, they are creating some matrix, right? For user one, what is the permission they have? Right? User two, user B, what is the permission for this file? Read only. User S, they have only read write permission. They are not ownership permission, right? Origin permission is not there. Likewise, they can create a access control matrix. Based on that one also, they can implement the access control, right? So this is a list similar to the directory. Here they are using access control list, right? There's nothing. Yeah, they are defining these three things: who, what, how. So if you define these three aspects, who can access, what can access, how can access, that is the access control mechanism, right? We can use matrices or list or directory to do those things, right? So now we will complete the access control. The third one, cryptography. Now tell me why they introduced this cryptography. What is the initial uh, thing, or what is the initiation of cryptography? Why they initiate cryptography? Tell me.
Hiding the real information and
Yeah,
encrypted.
maybe the ancient people, right? They pass the messages, right? Maybe they're planning for a war, right? So they need to plan for a war in a particular country, right? So the king is in a particular place, right? The king passed the message to the soldiers or the people who in charge for these that forces, right? Now, what they can do, they write the message and they put on an envelope and send it, right? In the middle, what will happen? Someone can read the message, right? If that some some people work as intruders, they can read the message and they will pass the message to the opposition parties, right? Then what will happen? The opposition party will become more stronger than the people who plan to attack. Because of that, they lost the wars, right? To avoid those things, what they want, they need to hide the things. Even if they share something with some other parties, they need to hide their original meaning of the message, right? For that purposes, they introduce the encryptions, right? So the purpose of encryption to hide the original meaning or original source message, then they introduce the encryption. So actually, the problem is if you share an information among some other parties, there are so many things happen, right? We already discussed, right? Intrusion, interceptions, right? Modification and fabrication. We discussed in the first slide, right? These are the four possible things happen if you do a communication between two parties, right? Or sometimes what will happen if you send a message in the middle, the attacker stop. That is we can call interceptions, right? Sorry, interruption. Interruption in the sense he will block the message, blocking the message. Interruptions, right? Interception in the sense he will not share the original message, he will share the message, some fake messages, right? Similarly, they will modify the message. They are planning to do an attack by tomorrow. Maybe he told we are planning the attack by next month. Likewise, that is modification. Fabrication means you are not send anything, but some attacker or hacker send the message in the middle, right? To avoid those type of issues, they introduce these encryption, right? The cryptography, right? To to overcome the challenges of blocking the messages or interceptions or fabrication or modification of messages, they introduced the concept called encryptions, right? So I think you know what is encryption, right? I think you're familiar with these terms, right? So the person who sent the message, sender, the person who received the message, receiver, transmission medium by using the internet or which medium we are pass the message, right? That is a transmission medium. Uh, Interrupter in the sense the intruder in the sense he's the hackers, right? In the middle the other one look at the messages, right? The encryptions, encrypt means what? Encrypt or encode or encipher. If you have a plain text, we are converting into the cipher text, right? Unreadable format, that is we can call encrypt, right? If you have a cipher text, right, then encoded things, we can reverse back and get the original message, that is we can call decrypt, right? Crypto systems means the combination of all encryption and decryption technologies we can call crypto systems, right? Plain text means that real original message. Cipher text in the sense encrypted message we can call as a cipher text, right? So I don't need to explain more about. They already familiar these terms, right? Maybe in some security subjects you learn those things, right? Encryptions and other things, right? So just revise the things, right? So this is the traditional flow of encryptions, right? So if you encrypt one message in the sense, right, you have a message to pass for some other parties, right? So you are using a particular key to encrypt the message, right? Key in the sense maybe you are using some techniques, right? So maybe you can shift the each character by three letters, right? Or you are shifting the character by 10 characters, or you are shifting by something. That's the one that is we can call encryption techniques, right? So we are using a key, then the plain text is converted into ciphertext, right? This is the original message, right? So original message in the sense you are telling we need to do the attack tomorrow 8:30 a.m. right? So that's a plain text, right? So now you have some keys. By using these keys, you can the plain text you are getting a ciphertext encrypted message, right? By using this encryption technique, we can get the ciphertext. If you read the ciphertext, we cannot get the real meaning of the things, right? Then again, you use the same key, right? There are two types of encryptions, symmetric and asymmetric encryption. If it is a symmetric encryption, we are using the same key for the decryption as well, right? So this is Bob, right? Bob wants to send a message to Alice, right? So Bob get his plain text. He apply the encryption techniques by using Bob's uses the say particular key. Then he will share. He will not share the plain text. He will share the ciphertext, right, with the Alice, right? So Alice got that ciphertext. From the ciphertext, he cannot read anything, right? So now, similarly, the Bob passed the same key to Alice, right? Now tell me, if Bob uses the same medium to share that uh, key also, what will happen? Is it good practice or bad practice? So Bob has a key, right? If Bob shared that particular key, then only Alice can read the message. Alice can decrypt the message and read, right? So now tell me how the Bob send the key with Alice, right? If it is symmetric encryption, we are using the same key, no? So is it okay? Is it a good practice if the same medium he will send that cipher text, he uses the key also? Is it okay? Is it a
No,
good
sir.
practice? Why?
If there are any intruders intercept, then they can get the key, they can
Yeah,
decrypt the
very good.
message.
So if you are using the same medium to share that encrypted message, the ciphertext plus the key, if someone intrude, they can get the key as well as the message, then they can decrypt the message and read the information, right? So now what they can do, they need to find out the solution, right? It's very difficult to use the same key between two parties, right? Why I'm telling, just think about there are two entities, two people, do a communication, anyhow, they will share, right? But think about we have 100 students are there, right? So between 100 students, they need to share the private key. It's a big challenge, right? The two parties, it's okay. You have only one pair of keys. You can share between these two parties, right? Now just think about I'm a lecturer, right? I need to do a communication between all the 25 students here, right? All the 24 students, I need to do a communication, right? Now what will happen? I need separately maintain a private key, one key between each student, right? It's a big task. It's a complex task for me, right? To avoid those things, they introduce the concept called asymmetric encryptions, right? Rather than we are using one key, they are using the key pairs, right? So that is the concept of asymmetric encryption. So this is a normal traditional behavior. The encryption and decryption happen, right? So if you are Bob send a message to Alice, he apply the encryption and send that ciphertext. That ciphertext is decrypted by using Alice by using the uh, same keys, right? So the Bob need to share that key to Alice, right, to do the communication, right? So now we will look at the symmetric and asymmetric encryptions, right? So I think you already discussed those things, right? Am I correct? Or you don't have any idea? If you have an idea, that's why I'm speed up the things and going, right? I think you learned symmetric and asymmetric encryptions, right? Am I correct? RSA, 3DES. Likewise, you learned, right? Am I correct? Tell me. Tell me.
Sir, we learn, but we
Yeah,
I
okay,
don't
then
know that.
just I
Sir.
will, yeah,
You have knowledge about that?
okay, okay, yeah. So maybe if possible, next class I will implement some practicals, right? I don't exactly, maybe I will do some practicals also, right? How the encryptions happen, right? Okay, so now there are two types of encryption, symmetric and asymmetric. So the symmetric in the sense you are using the same key for the encryption and decryption, right? So they're explaining symmetric in the sense you have a plain text, you are using this key for encryptions. Also, you are using the same key for the decryptions, right? So the challenge here in the symmetric encryption, you have a challenge how you are sharing that key with two parties, right? That's a big challenge, right? If you have two parties, definitely you need to share that key between two parties. Then only the two parties can, one party encrypt the message, the next party can decrypt the message and read, right? So that is a challenge in the symmetric key encryption. So they introduce a solution, asymmetric encryption. Right? Asymmetric encryption in the sense there are key pairs. One pair of keys used for this communication, right? So it means uh, you have a pair of keys. One key we consider as a public key, another key we are consider as a private key, right? So the concept of this public key and private key, if you want to know how they are creating these key pairs, right? Just think about the prime number concept, right? So if you want, you can search how they are generating key pairs, right? So just search about prime numbers, right? Prime factors, right? Sorry, prime, not prime numbers. Just search about prime factors, right? Prime factor in the sense we can call yeah, that's I can say in Tamil, uh, முதன்மை காரணிகள், right? Prime factors, right? So by applying this concept, prime factors, they are creating the factors, right? So the prime factors in the sense, right? There are two big values, big, huge values. Then you are getting the multiplication of these values. We are getting a one value, right? So we are consider this big number and this number as a two keys, right? So there are some logics there, right? Just learn those logics. You don't need the mathematical things, right? If you want, if you have self-interest, you can learn what is the concept behind uh, public key encryptions, right? Asymmetric encryption, how they are generating the two keys, right? Yeah, if possible, I will share some video tutorials. You can look at those things, how they are generating those things. Maybe if we are doing a practical, we will look at those things, right? So now what will happen? The concept is there is a pair of key, public key and private key, right? So the public key in the sense we are, let's say I'm creating a pair of key for me, right? I'm creating a key pair for me. I'm keeping my private key with me. I'm sharing my public key to the world, right? So anyone can access my public key, but they can't access my private key, right? So now what will happen? The person, right? Let's say I need to communicate with the student A, right? Now what will happen? Student A already created a key pair, right? He keep his private key with him, he shared his public key with anyone, right? So that student have a two keys, public key and private key. He keeps he keep his private key with him. He shared his public key with anyone, right? So now, if I want to communicate with particular student, first of all, I need to find out that student's public key, right? That public key is available in the internet, right? Or maybe that public key stored in a particular database, public repository. From that repository, I find out the public key of that particular student, right? By using that public key, I can encrypt the message, right? If I encrypt that message by using someone's public key, only by using that private key, that key pair only I'm using public key of that student, right? Public key of the student, right? Public key of the student. If I encrypt the message, this message can decrypt only by using the private key of that particular student. That is a concept in asymmetric encryption, right? Key pairs, public key and private key. So I can get the public key of that particular student and encrypt the message and send to that particular student. That student, he uses his private key and he can decrypt the message, right? So the important thing, if I encrypt a message by using a particular public key, only I can decrypt the message by using that related private key, right? So in that key pair, that student only has that private key. By using that private key only, he can decrypt the message. Maybe if he uses someone other's private key, he can't do the things, right? Definitely, I will show you these public private key communication by next class. Maybe how we are send an emails, right? Possible, I will share some tutorials, right? Otherwise, you can give me some extra time, right, to do the practicals, right? Then you can easily understand. Now tell me that student need to reply for my email or something. How he can do? That student find out my public key, right? He need to find out my public key from the internet. Then he uses my public key and encrypt the message. Then he send it to me, that encrypted message. Then I can decrypt the message by using my private key, right? That is a communication happen in the asymmetric encryptions, right? Did you understand?
Yes, sir.
If you have any questions, please let me know, right? If you have confusions or if you not understand, please let me know, right? Based on your request, I put on online, right? Otherwise, I'm not accept to do online. Maybe some of the students are requested, they are going home. So that's why I put as online, right? So any questions? Okay, just differentiate, right? What is symmetric? Symmetric means only one key is used for the encryption and decryption. Asymmetric, they are using key pairs, public key and private key, right? So public key to encrypt, we are using public key of someone. We can decrypt the message using the private key of that particular guy use his private key to decrypt the message, right? That's the concept, right? Now, the another concept in encryption, we can categorize the encryptions in two types, right? Stream ciphers and block ciphers. These are the two terms we can categorize the encryptions, right? Block ciphers and stream ciphers, right? Stream ciphers in the sense we are encrypting the message bitwise, right? So we are taking the first bit, right? We can apply the encryption by using a key and get the decrypt message, right? So if you are doing bitwise, right, each bit each bit we can encrypt bitwise. We can call this is a stream ciphers. If we are taking a set of block, let's say we are taking 8 bits together, then we can apply the encryptions. That is, we can call block ciphers, right? So if it is a bit cipher, stream ciphers in the sense bitwise encryption happen. Stream ciphers in the sense bitwise encryption. We are taking the first bit, we will apply the encryption. We are taking the second bit, we apply the encryption. We are taking the third bit, we apply the encryption. Likewise, it will bitwise, we will do the encryption and decryption. That is, we can call stream ciphers. Block ciphers in the sense, at a time we are taking 16 bit together, we can apply the encryption, right? Similarly, we are taking first 16 bits to decrypt, right? That is, we can code block ciphers, right? We are taking a block of bits, and if we apply encryption and decryption, that is, we can call block ciphers. Stream ciphers in the sense bitwise encryption is happened, right? So I will play a video. Okay, just look at this video, then you can easily understand, right? There's a simple example for stream ciphers and block ciphers. So these are some examples for block ciphers, right? So block ciphers in the sense, DES, data encryption standard, DES algorithm, triple DES, right? AES. So I think you learned those things in your cryptography subject. I don't know exactly, right? So you are detailedly discuss those things, right? So if it's a block cipher in the sense, they are taking a block of uh, bits together and they will apply the encryptions, right? If it's a stream cipher, they take bit by bit, right? They are taking the first bit, apply the encryption. They are taking the second bit, apply the encryption. That is the way they will do, right? So now we will look at the advantages and disadvantages of these two, right? If you think about the advantages of stream ciphers, right? Stream ciphers in the sense each bit they apply the encryption and decryption, right? That is the speed of the transmission is high, right? Also, the advantage is low error propagation, right? The error occurrence possibility is very low. Why? We are taking each bit by bit, right? So the error occurrence probability is very low, right? If you think about the block cipher, the advantage is high diffusion. The diffusion in the sense, right? In the block cipher, we are taking, let's say, 16 bits together, right? If you do a small change in the plain text, your entire cipher text will be changed. That is, we can call diffusion, right? So diffusion in the sense, just think about you have a plain text message. If you change one character, it will impact the entire message, right? If it is a block cipher, what will happen? We are taking the 16 bits of letters. If your message, you have 16 characters, and you are taking 16 characters together, then what will happen? If you do a small change in the one character, your entire cipher text will be changed. That is, we can call high diffusion, right? So you can read this. Diffusion means the change in a single bit of plain text, then half of the bits in the cipher text should be changed, right? So high diffusion in the sense, if you do a small change in the plain text in the block cipher, it will impact half of the bits in the cipher text will be changed, but not the case in stream cipher. Why? Stream cipher, we are taking bitwise, right? So if you are taking one bit, so if you do a say change, it will change, right? So that low diffusion is happen, right? Because we are taking only one bit, right? So because of one bit change, that is not high diffusion, low diffusions, right? So similarly, if you look at the disadvantages, susceptible to malicious insertion and modification, right? So if you are using a stream ciphers, right, we are taking one bit, right? There are so many possibilities to malicious insertion happen or modification happen in these, right? Also, block cipher is a little bit slow compared with the stream ciphers, right? This is high error propagation, right? So we are using that set of bits, no? So therefore, this is a high error propagation, right? So these are the comparison of block ciphers and stream ciphers, right? Mm, yeah, yeah. Okay, give me 5 minutes. I will try to finish that, right? So asymmetric encryption, right? I already explained, right? Instead of two users are using the same key, in the symmetric encryption, they are using the same key. But if it is asymmetric encryption, public key encryption, we are using key pairs, one public key and one private key. So this is explained by these commands, right? Uh, so message encrypted using the user's public key can only be decrypted using the private key, right? That is a concept, right? That is vice versa also possible, right? If you are using one person's private key to encrypt, you can decrypt by using that public key of that user, right? If you have a key pair, right? Just think about if you have a key pair, if you encrypt a message using your private key, only you can decrypt using the public key. But that is not a good communication. Why? Why I am telling that is a good communication? Public key is available for each and everyone can access, right? So if you encrypt a message using your private key, then anyone can find out your public key and decrypt the message, right? So that is not a good practice. That's why we are using public key to encrypt. Then that particular guy only decrypt the message using his private key, right? So the good practice, they are encrypting using the public key, and we are decrypting the message using the private key. But some scenarios, we are using the vice versa also, right? We will discuss those things in the next class, right? In some scenarios, we are encrypt the message by using the private key, and we are decrypting the message using the public key also possible, right? I will explain next class, right? Some different digital signature or handshaking, those things are uses some vice versa also, right? So these are the comparison of public key and private key encryption, right? Private key encryption means symmetric key encryption. Public key encryption mean uh, asymmetric encryption, right? Symmetric and asymmetric. Number of key involves symmetric, only one. Here, two keys, right? The size of the bits, 64 to 120, 112 bits for data encryption standard. DES algorithm, AES 128 to 256, right? Here, it's a public key encryption that is unlimited, right? Protection of keys must be secret, right? If you have only one key, you definitely secure that key, right? But in the public key, only you need to secure the private key. You don't need to worry about the public key, right? That is publicly available. One key must be kept secret. The other key freely available for anyone, right? Best users, cryptographic workhouses, right? Key exchange authentication, right? To exchange a key between two parties, we are using the public key, right? Key distribution must be out of band. Public key can be used distributed other keys, right? Very fast. Symmetric is very fast because they are using only one key for both. But public key encryption, asymmetric encryption is slow compared with the uh, private key encryptions, right? So yeah, just think about how they will exchange the secret keys, right? Just think about Bob and Alice. Maybe Bob and Alice need to do the communication, right? What they need to do, right? First thing I already explained, right? If you need to do send a message to someone, some students, I need to find the public key of that guy, right? So then what I need to do by using that particular guy's public key, I can encrypt the message, right? Then I can send the encrypted message for that student. That student use his private key and decrypt the message, right? So anyhow, if it is a symmetric key encryption, right? First thing, by using some other mediums, they need to do the key sharing, right? So if you are using symmetric key encryption, first thing, we use a different medium and we can share the key between these two parties. After that, we can do the communications, right? So we cannot use the same medium to transfer the key as well as the text messages, encrypted messages. If you are doing these things, maybe the intruder can observe or they can listen the communication happen, right? So these are the summary of the things what we are discussed, right? So we discuss what is authentication, what are the different types of authentication features we are using, right? Then we discuss access control mechanisms, right? Then we discuss cryptography, how we have two different types of encryption. These are the things up to now what we are discussed. Any questions?